in order for us to be able to troubleshoot the 802.1x authentication, let's take a look in a little bit more detail. How does the whole process actually happen? How does the client device go from requesting access to the network to being fully authenticating and actually passing traffic? So the wireless device will discover the network it wants to connect, and it will see that there's a network, or the particular network it wants to connect to is protected with 802.1x EAP. It will then invoke the supplicant, which is the piece of software on the operating system that will be responsible for the 802.1x authentication, and that will initiate an EAP over LAN start. That starts the EAP authentication protocol. The authenticator, the AP in this case, in a wired scenario it would be a switch, will keep two ports open. One port is called controlled port, the other one is called uncontrolled port. And the controlled port is the port that the client would normally use to pass traffic to the distribution system, whereas the uncontrolled port is open and unblocked, but it's only allowing one communication stream, and that's the communication stream between the supplicant and the AP, which is then forwarded directly to the radius server. So that allows the end-to-end communication between the supplicant and the radius for our EAP protocol. So if we've initiated the EAP protocol, the access point will request identity from the supplicant. Now there's multiple ways of doing it, there's multiple types of EAP. In some cases, before the identity is actually passed, there's going to be a TLS or an encrypted tunnel built to protect the authentication. What we're seeing here on the screen is just a general framework of the messages that are exchanged, but depending on the EAP type that you're using, this may be more extensive or less extensive depending on what kind of credentials you have and which type of EAP you're actually using. So the next step that needs to happen is the access point requests the supplicant to identify itself. The supplicant will respond with a username. Again, if this is a protected version of EAP, or if you're using tunnel authentication, the username over here is going to be a bogus or anonymous. If it's one of the weaker types of EAP, this could be an actual username. And the authenticator now has enough information to pass a radius access request back to the radius server. And the radius server will then, depending on the username, or whether it knows the user identity, send an access challenge, which is, okay, so I think I know who you are. Now, please prove that you actually know a password or a credential. Please prove to me that you are who you claim you are. The AP simply relays that message back to the supplicant over wireless. And then a hashed response is sent back from the supplicant to the AP and then relayed to the radius server. And if the credentials are correct, if they match with whatever is in the user database, a PMK is going to be generated and passed from the radius server to the authenticator, to the AP. Now the PMK is a very important object in here. It's called a pairwise master key. And the pairwise master key is a direct result of a successful authentication, and it's then used in a four-way handshake mechanism which generates the encryption key. And the PMK and the distribution of the PMK key is essential for roaming to work. So you don't want this whole process to happen every time you roam from one AP to another. You want this to be done once, because it could take a second, maybe 2 seconds, depending on where your radius server is. And if you're roaming, if you're using real-time traffic, you don't have 1 or 2 seconds to spare. You want this to happen in tens or maybe 100 milliseconds max. So for that reason, that PMK is going to be cached on the AP and sent to the other APs by the distributed control or cooperative control protocols. Once the supplicant or the client is authenticated, the authenticator or the access point opens up the controlled port and lets the client traffic pass. Now, at this stage, this is where the client device gets its IP address. Prior to that, it does not have an IP address. So all the communication that happens before is simply relaying messages over the wireless to the radio server. The client device has no IP address at that stage. Only when the access is granted will it obtain an IP address, which is very important to remember when you're troubleshooting an 802.1x authentication. To reduce the complexity of 802.1x troubleshooting, the ExtremeCloud IQ platform will already interpret some of the messages and some of the workflow that happens at the background and try to either give you a description of the root cause or try to tell you what to fix in order to fix that 802.1x authentication. Because if you don't have that sort of insight, it may be troublesome to get to the bottom of why your 802.1x authentication is failing. Some of the possible causes that the platform will identify for you and that often happen in an 802.1x scenario is incorrect shared secret configured between the authenticator and the radio server. And that will be immediately pointed out in the troubleshooting part of the ExtremeCloud IQ. Incorrect settings on the access point or the radio server. So the access point is pointing to the incorrect radio server, or the radio server itself doesn't have the client IP address or the subnet of where the access points are configured on its client list, and therefore it's blocking all incoming radius requests from there. Incorrect authentication port used. So by default we're using port 1812. However, for security reasons, some companies change this port to something non-default. In that case, you'll have to find out what that port is and reconfigure it on the access point through ExtremeCloud IQ. The troubleshooting tool will generate a ticket or an event for every client device that is failing its authentication. Now, this doesn't have to be the 802.1x. It could be other types of authentication, and then through that event you'll be able to drill down to see what's actually happening, when it's happening, on which access point is it happening, and you will have really two things that are important. One is going to be what's the description of the event. In the case we use on the screen, you see the access point could not reach the radio server, and then the suggested remedy is, so how to fix the problem, is verify that the radio server is up and reachable over the network, which means we don't have IP connectivity between the access point and the server, and this is pointed out to you by ExtremeCloud IQ in the graphical user interface. Let's explain how machine learning insights can be interpreted and how the data that's being populated in there can be interpreted by a network administrator, and what kind of insights are we getting. So we'll take a look at one location, which is called CSE Mart Store 1. It's on 9th Northeastern Boulevard. It's floor 1. We have a couple of APs in here. And so this is the planner view. We've done this in the first lab. What we're interested in is the Network 360 monitor view. So let's switch to that. And the monitoring view, such as you see in here, will focus down on either a specific floor, building, or location, or a campus, or your whole global network view, depending on what you select in the location hierarchy. So this is why we said the location hierarchy is very important when you're setting up your ExtremeCloud IQ account. And up here, you will see scorecards. So you will see scorecards for different categories. Devices scorecard, client scorecard, Wi-Fi scorecard, network scorecard, services scorecard, and you'll see applications and security. So we'll go into each one of these individually, and we'll check what kind of insights can be obtained by looking at this data. So let's go in devices first. So when we looked at our access point, the one that we have configured and connected, we've already seen, there was some overall scoring available. Now this is the scoring available for the whole network, for all of the devices that we have in this particular location that we've selected. And let's expand the view to 24 hours to get some more dynamics in there. Okay, so in terms of overall health of devices on this floor, we can see that the overall health is 98 out of 100. And again, device availability seems to be constant. hardware is performing well, there's no hardware issues, and the only reason why we have a penalty is configuration and firmware score. So it's either that some devices don't have configuration fully in sync, or that some of them are using an old firmware. And if we see in here, we see 3 devices have pending configuration updates. So that's one part of the score reduction, and the other part is, oh, actually that is the only part. So all of the access points are running the current version of Hive OS. In terms of hardware health, so CPU load is not very high, memory usage not very high, and there's enough power supply, so there's no PoE issues. Scrolling down, this shows us, from a network perspective, the capabilities of client devices in this network, and we see 7 clients reported supporting 2.4 channels, but we'll just ignore 2.4 and focus on 5 gigahertz. So in 5 gigahertz, we have 11 clients claiming they support Uni 1, Uni 2, Uni 2 Extended, and Uni 3. So there's no clients outside of that, and there's no, you can immediately see that all clients that are on the floor support all channels. So you don't have any issues with clients not being able to support either DFS or Uni 3 channels. All client devices support 80 megahertz channels. There's 10 devices that are 1x1 through 1 capable, and then 12 devices that actually have 2x2 capabilities as well. And we have all devices capable of 802.11 AC with maximum transmit power of 30 dBm. Okay, so this is the overview of your network. This is how your network is performing, and if you see this health line over here on the top, there's no dips in the network health in the last day. Let's expand this to a week. Okay, wait for it to sync. And you see during the last week, there's no dips in health as well. And if we expand this to a month, which will take a little bit longer to sync. Okay, no dips in Wi-Fi health as well. But this is where you would quickly be able to determine, did your Wi-Fi health change? You'll be able to correlate that to any particular events. For example, down here, you can see channel change events on the access points, and if the network health would be changing or dipping at the same time as one of these events would be happening, then you can immediately correlate, oh, this was probably the cause for the dip in our network health. And yeah, down here you can see that this particular network is actually quite healthy. The only thing that we have is we have 3 access points with Delta configuration push pending, but everything else seems to be running A-OK. So this is device health.